Okay, now let's do the 23rd problem. Okay, find the limit of the function when x is approaching 0, and second one, limit of the function when x is approaching 1. Okay, now here the function is f of x is equal to 2x plus 3 when x is less than or equal to 0, 3x plus 1 when x is greater than 0. Now you see here we have two functions. Okay, f of x is this and f of x is this. Two functions we have. In earlier problems from 1 to 22, we had only one function. Okay, that was like example. See, if you take limit, let's take this. Okay, 2x plus 3, then find the limit when x is approaching 0. Then if you take the number line, see, if this is 0, this point is 0, x is approaching 0 from the right side and x is approaching 0 from the left side. Okay, so here we just assume as x is approaching from both sides, because the function here is for all the number line is okay, it's for all the real numbers. Here we have only one function for all the this number line, or for the real numbers. Okay, so when x is approaching from both sides, is approaching to 0, then we assume that x is almost 0, and we put the value of x in the function, that is 2 multiplied by 0 plus 3, which is 0 plus 3 is equal to 3. This was how we did earlier. Okay, now when we have two functions, it will be like this. See, so if you take the number line again, if this is 0, if this point is 0 and x is approaching 0 from the right side and x is approaching from 0 from the left side, then you see here it's given that x greater 0 is this function and x less than or equal to 0 is this function. That means this is 0, x greater means this side, greater than 0 means the function is 3x plus 1, and if it is equal and less than, 0, then it is 2x plus 3. Okay, 2x plus 3, this is the function here. So we have two different functions from the right side and for the left side. So we have to find two limits, that is left hand limit and the right hand limit, because we have two functions. Okay, earlier we had only one function, so the limits were same from both left and right. Okay, now here we have to find two limits because it has different functions. Okay, that how it is done is, now we see now we will take the left hand limit. Okay, LHL, it is known as LHL, left hand limit. Now when x is approaching 0 from the left side, okay, you take it as limit of the function f of x. Okay, when x is approaching 0, from the left side, so we give here a marking, that is dash, 0 negative or 0 minus or dash, which indicates that it's moving from left to right. Okay, left hand limit, this is left hand limit, symbol of left hand limit. So limit f of x approaching 0 from left side, so then we write limit, the function is 2x plus 3. Okay, from left side, 2x plus 3, x approaching 0 from the negative side or from the left side. Now we put the value of x in the function and we get 0 plus 3, 0 plus 3, which is equal to 3. This is the LHL, left hand limit. Okay, when x is approaching from the left side. Now right hand limit, RHL, right hand limit. Now when x is approaching 0 from the right side, we write it as limit of the function as x is approaching 0 from the right side, that is marked as positive plus. Okay, plus means from right hand side, from the right side. So limit of the function as x approaches 0 plus, then we write it as limit of the function. The function is the right side, the greater than 0 is 3x plus 1. Okay, as x approaching 0 plus, now we put the value of 0 in the function, we get 3, 0 plus 1 then it becomes 3. 0 plus 1 is 1, which is equal to 3. This is the right hand limit. Now you see the right hand, left hand limit and the right hand limit are equal. If the right hand limit is equal to the, if the left hand limit is equal to the right hand limit, it means there exists limit at this point. Okay, the limit exists at this point. If it is not equal, there is no limit. Okay, so these are now equal. Here it's 3, left hand limit is 3 and right hand limit is 3. So we have limit, the limit exists here. Okay, so we can write, therefore, since LHL is equal to right RHL, therefore limit of the function exists as x approaches 0. Therefore limit of the function is, as x approaches 0 is equal to 3. This limit, because these both are equal, limit exists and the limit is 3. Okay, this is how it is done. Okay, now this is the normal method, but the real method is the method of H, and that we'll do in the next video. Okay.